Hello,
You are now unmuted.
hello,
You are now muted. You are now unmuted.
hello. Good afternoon, guys. So today we are going to start with definite integral. Okay. So we have discussed about indefinite integral in previous lecture, but in this lecture we are going to discuss about definite integrals. So can anyone tell me what do you supposed to mean definite integrals? What is the physical or practical meaning of definite integral? Okay. In indefinite integration, we have solved simple integrals, okay, but if we need an integral with the defined limits, let's suppose we have a function y equal to fx. This is the function, okay. So let's suppose this is the curve of this function fx. This is x-axis and this is y-axis. To this point, let's suppose a. This point is x equal to a, and this point is x equal to b. Oh, okay. So if we need to find out the area under this curve, then we need to limit the integration from x equal to a to x equal to b. Then we have to find out integral of fx into dx starting from a to b. We put the lower limits a, that is starting limit, and upper limit b, that is final. That is equal to area under the curve. Yeah, area bounded by that curve starting from x equal to a, finishing at x equal to b. This is the physical meaning of definite integral. We need to find the area under that particular curve. Okay. So is there any doubt about this? Okay. So now let us try to find out how this area is equal. Okay. So let's suppose in similar way our function is y equal to fx. Okay. So let's suppose this is x-axis and this is y-axis. Okay, so starting from point x equal to a, this point, and ending at point x equal to b. Okay, so if I divide this area into small steps, let's suppose this point is like this, in small step, infinite steps, and width of that step is, let's suppose, h. The width of that particular step is h. So let's suppose this point is starting from x to, let's suppose this is x0 and this is x1, this is x2. So on this final, this point is, let's suppose, xn. Okay, so this is width is always equal. So we can say the point at xn, that is equal to b, is equal to a plus n times h. Can we write like this? Is there any doubt in this? Okay, so we are reaching from point A x equal to A to point x equal to B. So we simply add n times of h. Okay, so here, so we can simplify this to be got B minus A divided by n, that is equal to h, strip length. Okay, so now if we add all these area, all strips area, then we can say this is equal to the area of, let's suppose this is P, this point is Q, R, S. So if we add the area of each strip, starting from this first strip, second strip, and so on, all these strips, so then that area is equal to area of PQRS, isn't it? So if we write what is the area of first strip, so if the strip is very narrow, that is small, so we can consider this is equivalent to a rectangle. Okay, so we can say this is the width and this is the height. So we can write the area of first strip as h into f of a. Similarly, for second strip, for this strip, okay, this next strip we can write area as h into f of a plus h. Okay, so we can write h into f of a plus h, isn't it? We can write like this, and similarly so on up to n terms. So final last term will be h into f of nh. Okay. So this is equal to our area A. Okay, so we can see. So if we take h as a common from all this term, then we can say by taking h as a common, we have f of a plus f of a plus h, f of a plus 2h, so on up to f of a plus nh, isn't it? Okay, so if we write in terms of sigma, can we write like this? H sigma of f of a plus h nh, where n is started from 0 to n. Okay, can we write like this? And this is equal to area of PQRS, that curve. Okay, so here if we substitute the value of h, what is the value of h? We have calculated here. This is the value of h, isn't it? So if we substitute the value of h here, then we have finally b minus a divided by h, no, sorry, divided by n. Here, divided by n, and that is equal to sigma of n0 to n1 f of a plus nh. Okay, so if we assume, okay, this area of PQRS, okay, if we assume if n tends to infinite, that means number of steps are infinite. Okay, or we can say first, if h tends to 0, that means the width of strip is tends to 0, that means strip is quite narrow, then n tends to infinite. Okay, the number of strip will be infinite. If we apply that condition on this given equation, then we can say limit n tends to infinity b minus a divided by n sigma of n0 to n f of a plus nb, that is equal to area of starting from A to B fx dx. This is known as area integral in form of limit. Okay. This is how we convert the area into sum of a limit. Okay. This is very important equation. So if we take A as a 0 and B as a 1, A as a 0 and B as a 1. Okay. So then this equation turn out to be, if we take A as a 0 and B as a 1 in this equation, then limit n tends to infinity, then 1 by n, that means sigma of, this is f of nh, this point is h, this is h, this is nh, okay. So we can say starting from n 0, so we can take approximations कि instead of 0 we can start with n equal to 1 to n. Okay, so this equation, this will be equal to 0 to 1 fx dx. Okay, simply. So this is the kind of equation we are going to use to convert this integral into sum. Sometimes some integrals or some limit into integral. This equation. Okay. So if we have given this like limit n tends to infinity 1 by n sigma of f of r by n, and r tends to either 1 to n. Okay, r tends to 1 to n. Okay, so we can convert this into a integral. That integral is equal to 0 to 1 fx dx. So how do we convert this integral? So we need to substitute 1 by n as dx and r by n as x. Okay, if we put the limit on this r, if r is 1 and n tends to infinity, then limit on x is 0. If we put r equal to n, then n by n is 1. So this limit is equal to 1. So this equation is very important equation to convert a limit into integral, a limit into integral. This integral is quite useful. And last 2 or 3 years, we have observed that lots of questions have been asked from this particular equation. Okay, so let us try to solve few questions based on this particular equation. Okay, so my first question is that limit n tends to infinity. Okay. Find out this limit 1 upon n plus 1 into n plus 2 plus 1 upon n plus 2 into n plus 4, so on up to 1 upon 6, and this limit we need to calculate. Try this question. Can you solve this question now? Try this question. There is an n outside here. We have an n in multiplication. Can we simplify this? First, make a sigma form of this like this. How do we represent this in sigma form? generalized sigma form of this. Try to make generalized sigma form of this. Okay, so if we look here n plus 2, so here this is one increment, this is increment of 2. So we can say basically this is n divided by n plus r, n plus 2r kind of general term. Okay. So if you put r equal to 1, we got this term. So if you put r equal to 2, we got this term. And sigma r1 to n. And here limit is same as limit n tends to infinity. On this equation, here limit is similar, that is n tends to infinity. Isn't it? So if we rearrange this equation, we can write limit n tends to infinity, limit n tends to infinity. Okay. Sigma of n upon n plus r, n plus 2r. Here, r value is starting from 1 and finishing at. Okay. So now we are trying to make in the form of r by n. So again we rearrange, then we can write like taking n common from this factor and n common from this factor. So we have sigma limit n tends to infinity. So n r equal to 1 to n. Okay, so taking n common from this factor and this factor too. So we have n divided by n is taking as common 1 plus r by n. If we take n common from this factor too, then we have 1 plus 2r by n. So this n get cancelled. 1n. Okay. So now we look at the substitution. What is our substitution criteria? R by n is equal to x and 1 by n is equivalent to dx and limit is 0 to 1. If we convert this into sigma into integral, so we can write now this equation is equivalent to sigma limit n tends to infinity r1 to n, that is 1 upon n, 1 plus r by n to 1 plus 2r by n. Okay, that is equal to 0 to 1. That means dx 1 by n, that 1 by n is dx. This is equivalent to dx divided by, that is equal to 1 plus x, and that is equal to 1 plus 2x. Okay, this is the final equation. Now we need to integrate this equation. So can you tell me what is the integral of this equation now? Starting from 0 to 1, dx x plus 1, 1 plus 2. How do we integrate this kind of integral? By using partial fraction. So if we make partial fraction of this equation, then we have to write how to do partial fraction. Any idea about partial fraction? Partial fraction. Anyone? Tell me what are the partial fraction of this equation? Can anyone tell me what is the partial fraction for this equation? So we can write like integral a upon x plus 1 plus b upon second factor 1 plus 2 into dx. We can write like this. Okay. So if we simplify this equation, then finally we have, like, if we look for the numerator in this section, we have numerator part is a into 1 plus 2x and b into x plus 1. So here x a into 2ax plus bx plus b. So here x is common, 2a plus b and a plus b. Okay. So now if you simplify this and compare with here the denominator of this part, the denominator is only 1, the constant 1 here. So we can say this constant value a plus b should be equal to 1 and 2a plus b, that should be equal to 0 because there is no term of x in denominator. So if we simplify these two equations, okay, so if I write a plus b equal to 1, subtracting these two equations, then I have a equal to minus. Okay, if I substitute a equal to minus 1, then b equal to 2, isn't it? Okay, so if I substitute here value of a and b in this particular equation, okay, so let us try to calculate this integral. Okay, so if we substitute the value of a 0 to 1, what is the value of a? Value of a is minus 1. Minus 1 divided by, what is the dividing factor? X plus 1. X plus 1. And what is the value of b? 2. 1 plus 2x into dx. This is the integral finally. Okay, this is the integration, isn't it? Okay, so now we need to calculate this integral finally. So we can say the first integral is minus log 1 plus x and limit will be 0 to 1 plus. This is 2 log of 1 plus 2x divided by 2 and this 2 get cancelled and here again limit will be 0 to 1. Okay, so is there any confusion now? So if you simplify this by putting the limit, if I put 1 upper limit here, then finally I have minus log of 2 and minus 0. Here we have log of 3 and finally log 1, that is 0. So I can write log 3 minus log 2 and that is equal to log of 3 by 2. That is our final answer for this limit. Okay, so this is our final answer. Is there any doubt now? You can ask. If you have any doubt in this question, you can ask now. First, anyone, if you have any doubt regarding this question, you can ask. Okay, so can we try one more problem now? Okay, fine. Let us try to solve one more problem. Okay. Okay. This time problem is limit. This time our problem is limit n tends to infinity. Okay. And what is the equation? Sigma of, now we have given a sigma series. K equal to 1 to n and k divide over n square plus k square. We have to find this limit. Okay, so now try this time. This is your turn to solve this now. Okay, so try this question, take 1 minute of time and tell me the answer in comment section. Try to solve this question fast. Use similar same concept we have discussed earlier. First, try to convert this sigma into integral equation. Okay, so I have explained how to convert this equation into integral equation. So try same procedure. Try to follow same procedure. Okay. Okay. Fine. Okay. Look. So I told you first we need to convert this integral into this sigma into integral. To convert this integral into sigma, first we need to take n square common from denominator. Okay. So if I take n square common from denominator, that is k equal to 1 to n. Okay. K, if we take n square common, then I have 1 plus k square by n. Okay, this is the equation. Okay, so here limit n tends to infinity. Okay, so now if I simplify this again, so I can write this taking 1 n from this n square, k by n, and here we have n, and this is 1 plus k square plus n. Okay, you can write this equation like this. So here sigma is same. Okay, the sigma of k equal to 1 to n and limit is same, n tends to infinity. Okay, so now if we substitute here, if we let k by n equal to x, okay, and 1 by n into dx. So what is the limit? How to find out limit? If we put k value here, if we put k equal to 1, k equal to 1, then n value will be 0. Then x value will be 0 because n tends to infinity. So here the value of x will be 0. Okay. If k equal to infinity, if k equal to infinity, or we can say k equal to n, then x value equal to 1. So our limit on x is 0 to 1. So we can write this as integral 0 to 1 x upon 1 plus x. This is x. So this 1 by n is our dx. This is the final integral we need to calculate. Now this is a easy integral. Can you calculate now? Now, can you tell me answer now? Can you tell me answer now for this question? Okay. So we have 0 to 1 x upon 1 plus x into dx. So we have 1 plus x square plus t. Okay. So if we differentiate this equation both sides, then we have 2x dx equal to dt. We have x dx 1 by 2 dt. Okay. So now if I substitute this in this equation, so finally first we are trying to find out the limit. Okay. So we are trying to find out. Okay. Let us first integrate this. Okay. So we have 1 by 2. Okay. So here x dx value will be 1 by 2 into dt. and divide by t, isn't it? So if we integrate this, then I have 1 by 2 log of t. Okay, if I substitute back value of t, then we no need to convert the limit into t. Okay, so we can use the same limit of x. Okay, so if we substitute the value of t back, 1 by 2 log of 1 plus x. Okay, now we can use our previous limit, that is 0 to 1. If I use 1 here, then I have 1 by 2 log of 2 and 0. So this our answer is log 2 divided by 2. This is the final answer. Okay, for this question. So is there any problem or doubt in this? Okay, it is not necessary every time we got the limit 0 to 1. There are some cases we got different limit. Okay, so how do we get different limit? Is there any idea? No. If this is the multiple of n, if this value here, the upper limit is multiple of n, like say 2n, 3n, then we get this value as 2, 3, 4. Like, okay. So now tell me, is there any problem in this? इसमें कोई दिक्कत हो तो बोलो. Okay, fine. Okay. So I think there is no problem in this section. So let us try to move forward. Okay. So let us try to solve few things. Okay. So we have a question here for definite integral. Okay. So we need to find out the value of integral 0 to pi. This is pi. Okay. Integral dx 1 plus 2 sine square x. Okay. So try this question. Try to solve this integral. How do we simplify this? Okay, just take your time and try to solve this question. Just take your time and try to solve this question fast. Is there anyone who got the answer? Is there anyone who got the correct answer? No. Okay, let us try to solve this. How do we solve this? Okay, so first we need to convert this 1 into trigonometric identity, that is cos square plus sine square. Okay, so if we write here I is equal to here, if we write I is equal to 0 to pi into dx divided by the value of this one as a sine square x plus cos square x plus 2 sine square x. Okay, so if we simplify this, then we finally have 0 to pi dx, that is cos square x plus 3 sine square x, isn't it? Okay, so this is the value of this. Okay, denominator. So now tell me how to solve this kind of equation. So we must divide numerator and denominator by cos square x. So divide numerator and denominator by cos square x both. Okay. So if we divide numerator and denominator by cos square x, then I have 0 to pi 1 upon cos square x into dx. Here I have cos square x divided by cos square x plus 3 sin square x divided by cos square x. Okay, so now if we simplify this, then finally we have 0 to pi sec square x into dx. This is 1 plus 3 10 square x, isn't it? This equation is like this. Okay, so now tell me what is the substitution for this equation? Can anyone tell me substitution? What we need to substitute now? 10 square x equal to p or 10x equal to t. We need to substitute here 10x equal to t. So let 10x equal to t. Okay, so differentiating this equation both sides, then we have sec square x dx equal to dt. Okay, so making this substitution in this equation, so finally we have integral. We are not converting this. We can also convert limit 10 0 is 0, but at pi is also 0. So this is making some mistake here. So can you tell me what is the problem now in this concept? So this substitution is valid or not? Because if we are converting this into back into limit, then there is a problem. Okay, so can you tell me this substitution is possible or not? So here this substitution is not valid because we cannot substitute this, because if we check for the limit, okay, if we check for limit when x is 0, when x is 0, t is also 0, and when x is pi and t is also 0. So this is not a valid substitution. Okay, so sometimes we have a problem like this. We substitute something, but that is not a valid substitution. So in this case, we cannot find out what the integral value is there. Okay, so we need to think of some alternative method either, or either we can say we cannot calculate. Every integral is not possible to calculate. So, okay, are you getting my point? So this is not a valid substitution. So this is the mistake in this kind of question by if we are making the, but if we need to calculate this integral without limit, then we can assume this substitution as a correct. Okay, if this limit is not there or if this limit is something different, then we can assume this substitution, then there is a no problem. But if 0 to pi, then this kind of substitution is not possible. Okay, are you getting my point? Okay, fine. Okay, so this is invalid substitution here, so we cannot solve this like this. Okay, fine. Okay. So, is there any doubt in this question? Why this substitution is invalid? Is there any doubt why this substitution is invalid? No. Okay, fine. Okay. Let us try to discuss some properties of definite integral. So what is the first property? First property is about area. Okay, so let's suppose we have curve like this. This is A1 area, this is A2 area, A3 area, A4 area. Okay, so if we take the area above x-axis, that is positive area, and that is positive area. This area is negative area, and this area is negative. Okay, so if we say this is some fx, let's say this curve is some fx. Okay, so this point is a and this final point is b. So if we calculate integral a to b fx dx, okay, then that will be equal to a1 plus minus a2 plus a3 minus of a4. This is equal to this way. Okay, but if someone asks about the area under the curve from x equal to a to x equal to b and y equal to fx. If someone talking about specifically area, then area value will be absolute sum of all area, a1 plus a2 plus a3 plus a. This is the absolute value. Okay, so this is the sum of all absolute area. Okay, so now tell me, is there any problem? So this is the first property, difference between area and definite area. If someone asks, use this word, find out the area, then we need to add each area. Otherwise, we need to take positive above x-axis, negative below x-axis. Okay, so is there any problem? So there is a second property, integral a to b fx dx. That is equal to negative of integral b to a fx dx. Okay, this is the second property. If we change this limit from a to b to b to a, if we reverse the limit, then there will be a negative sign. Okay, so there is a third property. If I have an integral from, let's say, a to b fx dx, so we can write, let's suppose this point is a and this point is b. Okay, here we have 2.1. Okay, so in between there are few points. Let's suppose c1 and c2. We can integrate first from this to this point, then this to this point, and this to this point. So we can break this integral as particular interval as a to c1 fx dx plus c1 to c2 fx dx plus c3, but there is no c3, so we can say c2 to b fx dx. These two area will be equal. These two integral will be also equal. Okay. So this is the third property. Okay. So is there any doubt in these three properties? First property is area above x-axis is positive, area below x-axis is negative. This is the first property. Okay. Second property is integral a to b fx dx is equal to minus of integral b to a fx dx. Okay. And third property is a to b fx dx equal to a to c1 plus c1 to c2 plus c2 to b. Okay, so c1 and c2 are in between a and b. Some points are in between a to b in continuous. Okay, but this property is quite useful when function have some point of discontinuity or definition of function change according to particular interval. Okay, so let us solve one question based on this property. So then you have a better idea about this. Okay, So question is that we need to find out I integration minus 1 to 2 mod of x cube minus x into dx. You need to find out this integral. Okay. So try this question and tell me the answer. Okay. Try to solve this question. This is based on third paper. So can you solve this question now? Try to break this function into that particular intervals that belongs to minus 1 to 2. Okay, fine. Okay, so we have, let's suppose this is fx. So we have fx as x cube minus x. Okay, so if I simplify this function, then I can write x minus x square minus 1, or we can write mod of x plus 1, x minus 1. Okay. If I check about the sign of this particular, okay, so we use vehicle, that is minus 1, 0, or that is plus 1. So we can say this is positive part, this is negative part, this is positive part, and this is again negative part. Okay. So we are starting from this point, x equal to minus 1, this point, and we are going to up to x equal to 2. So there will be some point here that is 2. Okay. So first interval will be minus 1 to 0. So here this is positive. Okay. So we can open this mod without any sign. So we can write this I is equal to first interval minus 1 to 0 x cube minus x into dx plus second 0 to 1, this integral will, this sign of this equation will be negative, so we need to use minus sign while opening this mod equation. Okay, so we can use minus, so that will be minus x cube plus x into dx. Okay, starting from 0 to, then again the sign of this equation in interval 1 to 2 is positive. So we can directly open this mod, we can write 1 to 2 x cube minus x into dx. So now tell me, now integrate this and tell me answer fast. Now integrate this fast. How to integrate this fast? Okay, so if you integrate this, then I have x to the power 4 by 4 minus x square by 2 minus 1 to 0. Isn't it first integral? Plus for the second, minus x to the power 4 by 4 plus x square by 2, limit will be 0 to 1, and finally third will be x cube x to the power 4, sorry, x to the power 4 by 4 minus x square by 2, that is 1 to 2. Okay, this is the final. Okay, so if you simplify this, so if you put 0, that is 0. If you put minus 1, so we have here 0 minus of 1 by 4 and plus of 1 by 2. Okay. And here we have minus 1 by 4 plus 1 by 2, and this is 0. So here we have 2 to the power 4, 16 by 4, that is 4, that is minus 2, minus 1 by 4 and plus 1. Okay. So if we simplify this, Then finally we will have, if we calculate this, finally we will have 11 by 4 as the final answer. This is our final answer. Okay, this will get cancelled with this get cancelled with this. No, this is not cancelling here. Okay, so we have, this is the final answer. Okay. So is there any doubt? You are following up to this? Okay, fine. Okay, let us try to solve few more problems based on this concept. Okay, so next problem is I integral minus pi by 2 to plus pi by 2. Limit is minus pi by 2 to plus pi by 2. Okay, so we need to calculate integration of under root cos x minus cos cube x into dx. We need to calculate this integral. Okay, limit is minus pi by 2 to plus pi by 2. So can you calculate this? How do we simplify this? Okay, so if we take cos x as a common from this, okay, so can we write, okay, so I'm not writing other than another thing, I'm just simplifying this concept. So taking cos x as a common, then I have 1 minus cos square x. Okay, again if I simplify this, then I have under root cos x and 1 minus cos square is sin square x, isn't it? So if I take sin square x outside this square root, then I can write this as under root cos x and mod of sin x dx, and limit is minus pi by 2 plus pi by 2. This is the change in result. Now we need to open this mode according to sign. So we need to break this equation into two parts. So first part where that sin x is negative, that is minus pi by 2 to 0. So we can break this integral into two parts. That is minus pi by 2 to 0. Okay, that is under root cos x minus sin x into dx. Okay, plus next is 0 to pi by 2, 0 to pi by 2, that will be under root cos x, and that will be positive sin x dx. Okay, so now tell me how to simplify this further. Now we just need to make substitution cos x equal to t. So if we make let cos x equal to t, then we have minus sin x dx equal to dt. So first integral, this integral will be under root t dt. Okay, so what will be the limit of t? If minus pi by 2, that means 0, and we can say 0 to 1, the limit of first integral. Okay, so what will be the limit of second integral? That will be minus, because there is positive, so we can say at 0, that is 1 to 0. Okay, so that is root t dt. Okay, So if we calculate this will be t to the power 3 by 2 divided by 3 by 2, 0 to 1 plus, basically minus sign is there. So this minus sign, we have t to the power 3 by 2 divided by 3 by 2, and limit will be 1 to 0. Okay. So if we simplify this will be 2 by 3 minus, this will be plus finally, basically 2 by 3. So final answer will be 4 by 3. So this is the final answer of this integral. Okay, so tell me, this property is clear to you? How to break interval? So is there any doubt? So there is few questions from uh, greatest integer function that need to solve in similar manner. Okay, so let us try to solve some question based on greatest integer. Okay, so I have this question. This is very good question. So question is 0 to 2 pi. Okay, greatest integer of sin x into dx. We need to calculate this integral. Okay, where this is greatest integer function. So can you tell me how to solve this now? Everyone aware of this greatest integer function? How this function behave? Try to calculate this integral. First, we need to break this in according to integral. So let us make the graph of sin x in 0 to 2 pi. This is the sin x, this is pi, and this is 2 pi simply. Okay. So if we talk about up to this point, pi by 2, up to this point, pi by 2, this is in between 0 to 1 because this value is 1. Okay. So this up to this point, the function will give us 0. Again from 1 to pi by 2 to pi, this again give us 0. Okay, so we can say in first interval in 0 to pi, the value will be 0. Okay, so now we need to calculate in second interval. Okay, so from here to here, there will be minus 1, isn't it? Okay, so if we look at when in this interval, when x belongs to, this is 0, this is pi. So greatest integer of sin x is mostly 0. Okay, because up to this point, pi by 2. First, so in both interval, this is 0. So the answer will be finally 0. So if we consider up to 3 pi by 2 and 2 pi. So here this is minus 1 and this value will be minus 1. Okay. So we can calculate this as integral minus, basically we can say pi to 3 pi by 2 minus 1. So in whole interval this is minus 1. So we can say up to 2 pi simply. Up to 2 pi minus 1 into dx. So we have minus x, limit will be pi to 2 pi. So that is equal to minus 2 pi plus pi. So final answer will be minus of pi for this integral equation. Okay. So now tell me, is there any doubt regarding this? Is there any doubt? Anyone? Come on, first. Okay. So let us discuss next property, fourth property. So fourth property is that if we have integral a to b fx dx, so we can write integral of a to b f of a plus b minus x into dx. There is no change in these two. Okay. So if sometimes this property is also written as when value of a like this 0 to a fx dx. This is also written as 0 to a f of a minus x. This is the version of this property, another version of this property. Okay. So this property is quite useful and used in lots of times we use this property. Okay. So let us try to solve few questions based on this property. So first question is pi by 6 to pi by 3. Okay. So under root sin x divided by under root sin x plus cos x into dx. This is very simple question based on this property. Try to solve this question. Try to solve this question. Let's suppose this integral value is I. Okay, so if we apply this property here, so what is the property? This property. If I apply this property, if integral a to b affects dx, that is equal to integral a to b f of a plus b minus x into dx. Okay. So if we apply this property on this, then we have I is equal to pi by 6 to pi by 3. Okay. So we have sine. What is the sum of these two angles? That is 90. So we can get sine pi by 2 minus x divided by sine pi by 2 minus x plus under root cos pi by 2 minus x into dx. Okay, so now if you simplify this, then we have finally I is equal to pi by 6 to pi by 3, that is root cos x divided by root cos x plus sin x into dx. Okay. So let's suppose this equation is 2 and our initial this equation is 1. Okay. So by adding equation 1 and equation 2. So finally we have twice of I, that is equal to integral of pi by 6 to pi by 3. So we have mod of cos x plus sin x divided by mod of sin x root of, okay, that is cos x into dx. So this get cancelled, this value get cancelled finally. So we have 2I is equal to pi by 6 to pi by 3. This is 1 into dx. So if we calculate this, that will be 2I is equal to x pi by 6 to pi by 3. So we have 2I equal to pi by 3 minus pi by 6. So finally that is equal to pi by 6. So I value will be pi by 12. This is the integral value of this integral. Okay. So tell me, is there any doubt? So may I? Okay. Let us try to solve one more problem based on this. Question is that minus pi to 3 pi. Okay. So log of sec theta minus tan theta into d theta. Okay. We need to calculate this integral. We need to calculate this integral. Now try this question. Okay. Apply that property and try to calculate this issue. Okay, let us try to apply that property here. So if we apply a to b fx dx, that will be equal to a to b a plus b minus x into dx, this property. So we can write I is equal to minus pi to 3 pi log of sec pi minus x or pi minus theta minus 10, not 2 pi. Okay. Here we have 2 pi minus theta, that is 2 pi minus theta d theta. Okay, so we need to calculate it. If we simplify this, then I is equal to minus pi to 3 pi. Okay, so we have log of, that is sec pi minus, that is sec theta, and this is minus minus again plus, that is plus 10 theta. This is equation 2 and this original equation is equation 1. Okay. So if we add equation 1 and 2 by adding 1 plus equation 1 and 2. Okay. So we have finally twice of I is equal to log minus pi to 3 pi log of sec theta minus tan theta plus log of sec theta plus tan theta into d theta. Okay. Pi to 3 pi. If we apply using logarithmic property of sum, so we can write log sec theta minus tan theta into sec theta plus tan theta. Okay, so if you apply this, then we can write 2i is equal to minus pi to 3 pi log of sec square theta minus tan square theta into d theta. What is the value of this? This value is 1 and log 1 is 0. So this is minus pi to 3 pi and this is equal to log of 1 into d theta. Log 1 is 0, so we can say final answer is 0. This is the final answer. Okay. So is there any problem in this? Is this any problem in this? No, no problem. All right. So I think this property is clear to you. We have solved pretty much questions now. This property. This is very important property. Okay. Always try to implement this property whenever you don't think anything work out. Okay, fine. Okay. So let us discuss next property, fifth property. So fifth property is integral 0 to 2a fx dx is equal to, first is this value is equal to 0 if f of 2a minus x is equal to minus of x. This value will be 0. And otherwise this value will be equal to twice of 0 to a fx dx if f of 2a minus x is equal to fx. Okay, this is the next property. So is there any doubt? And there is a similar property for even and odd functions too. If this integral is from sixth property minus a to plus a, let's suppose fx into dx. So we can break this integral as minus a to 0 fx dx plus 0 to a fx dx. Okay, so if this integral is equal to twice of 0 to a fx dx, if f of minus x is equal to fx, that means even function. Okay, in second case this will be 0 if this is an odd function. If f of minus x is equal to minus of fx. Okay, this is odd function. This is odd function. Okay, so this is our sixth property. So is there any doubt in these two property? Look at these two property. If you have any doubt, you can ask. Okay, let us try to solve one question. Here we have a question that is 0 to 4 pi. Okay, so question is 0 to 4 pi dx cos square x 2 plus tan square x. Okay, try to solve this question. apply that property and try to solve this question. Okay, so first we apply that property. Let's suppose this property. Integral 0 to 2a fx dx that is equal to twice of fx 0 to a. If f of 2a minus x is equal to fx. Okay, so 2 into 2 pi. First we need to break this integral, so we can write 2 into 2 pi. A value will be 2 pi. Fx into dx. So what is the value of fx here? What is the value of fx? So fx is dx, that is cos square x 2 plus tan square x. Okay, this is the value of fx. Okay, so that is equal to, if we apply this property, let us check f of a minus x is equal to. Okay, so 4 pi minus x, this is equal to x, and this is also equal to x. So we can write twice of 0 to 2 pi dx cos square x 2 plus tan square x. Isn't it? We can write like this. So now our final I value is twice of 0 to pi 2 pi. If we take this in numerator, that will be sec square x 2 plus tan square x, and this is dx. This is the final. Okay. So now again we apply this property. So we can also write this is equal to 4 0 to pi sec square x dx 2 plus tan square x. So I will be finally 4 into 2 8 0 to pi by 2 sec square x dx 2 plus tan square x. Okay. So if we substitute tan x equal to t, then we have equal to dt. So this equation will be 8 integral dt 2 plus t square. Okay. So now tell me the value of this. Okay. So if we simplify this, then I have 1 by a, that is root 2 tan inverse t by root 2. If you back substitute the value of t, then finally I have 8 divided by root 2 tan inverse tan x, and limit will be here, that is 0 to pi by 2. This value is outside, that is 8 root 2. So what is the final answer after solving this limit? Can anyone tell me? If you put pi by 2, so tan pi by 2 is not defined, so it's not defined. So tan inverse of infinity, that will be pi by 2, I think. Okay, so that will be pi by 2, and tan 0 is 0, again 0 is 0. So finally we have 4 upon root 2. We have 4, this get cancelled, pi upon root 2. If you rationalize this, then we have 2 root 2 5. This is the final answer for this question. Okay, so I think this is clear to you. Is there any doubt? Is there any doubt in this question? No. Okay, fine. Okay. So we have an important result. Try to remember this result. Sometimes we use this as a directly 0 to pi by 2 log of sin x dx or 0 to pi by 2 log of cos x dx. Can tell me what is the value of this result? Value of this result will be pi by 2 log of 1 by 2. Okay. This is an important result and try to remember this. Okay. Sometimes we use this result directly while solving the questions. So, is there any problem? No. Okay. So let us try to solve one question based on this. So question is 0 to pi x log sin x dx. We need to solve this. Okay. Try to solve this question. Try to solve this question. X log sin x. Try to solve this fast. We need to find the value of this integral I. So if we apply the property 0 to a fx dx, that is equal to 0 to a f of a minus x into dx. Okay. So if we apply this property, okay. So we can write I is equal to pi minus x log of sine pi minus x into dx. We can write like this. So if we simplify this, finally I have I is equal to, that is 1. This is equal to 0 to pi log sin x dx minus x log sin x dx, and limit is same 0 to pi. Okay. So if I transfer this integral value, because this is also I, so I can write this as I 0 to pi log of sin x into dx minus, can I write this as I? So if I simplify this, after simplifying this, then we have 2I is equal to 0 to pi. This is pi. Okay. So try to simplify this. So we can write pi log sin x dx. Now we apply the property of 0 to 2a fx dx, that is equal to twice of 0 to a fx dx if f of 2a minus x equal to fx. Now if we apply this property, so can you solve this now? Okay, if we apply this property, then finally we have 2i equal to twice into pi log of sin x dx 0 to pi by 2. Okay, so we have discussed the result of this integral. This result of this integral is pi by 2 log half. So we can say the final result will be this 2 get cancelled. So I is equal to pi by 2 log 1 by 2. So this result is pi square by 2 log 1 by 2. This is the final answer. Now check. Is there any doubt in this? Okay, I think this is clear to you. So we are trying to solve next question. So next question will be I is equal to integral of minus pi by 2 to plus pi by 2 log of a minus sin theta divided by a plus sin theta d theta, where a is greater than 0. Can anyone tell me answer of this question? Answer for this question. What is the answer for this question? Try to apply even and odd property. If we simplify with the help of even and odd function. So first tell me this function is even or odd. This function is whether even or odd. First try to tell me this. So if we simplify this, then I first check this function. A minus sin theta, a plus f theta. Okay, so if we apply minus theta, that will be log of a plus sin theta divided by a minus sin theta. Okay, so if we simplify this, so if we take reciprocal of this by using the property of logarithm, then I can write f of minus theta is equal to minus of log a minus sin theta divided by a plus sin theta, isn't it? So we can say f of minus theta is equal to minus of f theta. Okay, so this is an odd function, isn't it? So this is basically an odd function. So now if I apply the property of even and odd function, so I can say this is minus a2 plus a fx dx is equal to 0 if fx is odd function, isn't it? So that means minus pi by 2 to pi by 2 logarithm of, what is this logarithm? A minus sine theta divided by a plus sine theta d theta, that integral value is finally 0. Okay, this is the final answer for this question. Okay, so is there any doubt in this question? Okay, fine. Okay, let us try to solve one more problem, that is I equal to integral of minus pi by 4 to plus pi by 4. So integral of x to the power 9 minus 3x to the power 5 plus 7x cubed minus x plus 1 and divide by cos square x into dx. Can you find out what is the integral value of this? This is 9. This is 9 here. Try to simplify this expression. Try to break this into even and odd function. Okay, if we break this minus pi by 4 to plus pi by 4. So here we have 9 minus 3x to the power 5, 7x cubed minus x, divide by cos square x plus sec square x into dx. So this part, if you try to solve this part is an odd function, and this part will be even function, isn't it? Both of them. So this part is our odd function and this part is our even function. Okay, so if you simplify this, okay, so this integral will be 0. So because minus a to plus a property. So if we apply that property, that is minus a fx dx, that is twice of 0 to a fx dx. That means if fx is even, and that is 0 if fx is odd function. Okay, these two property. Okay, so finally the first part is 0. So left out integral value will be minus pi by 4 to plus pi by 4, that is sec square x dx. Okay, so tell me now what is the final answer for this? So if we apply the again property here, so we can write twice of 0 to pi by 4 sec square x dx. So this is finally equal to 2 integral of sec square x is 10x 0 to pi by 2. Okay, so this is 2, 10 by 1 minus 0, so final answer is equal to 2. This is the final answer of this integral. Okay, so is there any doubt? This is simply based on even and odd functions. If equation is complicated, try to analyze on the basis of even and odd function. If limit is from like minus a to plus a. So there is a hint by the looking at limit always. All right. So last property is about the periodic function. Okay. So if fx is periodic, let's go 0 to nt fx dx. So we can write n times 0 to t fx dx if fx is periodic with period t. Okay, so we can write like this. So let us try to solve question based on this. So we have a question, integral 0 to 100. Okay, x minus greatest integer of x into dx. What is the value of this integral? What is the value of this integral? So can anyone tell me x minus greatest integer of x? What is this function all about? So we can write x minus greatest integer of x is equal to fractional part of x. This is fractional part of x function. So can anyone tell me the about the period of this function? This is periodic function, but what is the value of t for this? What is the value of t for this function? What is the value of period for this function? So period value is 1. So we can write this as 0 to 100 into 1. This is fractional part of x into dx. Okay. So we can write in 0 to 1. This is 100 into, that is 0 to 1, and in 0 to 1 the fractional part will be x into dx. So if you simplify this 100, that is x square by 2, limit will be 0 to 1 finally. Okay, so if we substitute the limit value, then integral value will be 100 divided into 1 by 2, this get cancelled, so finally 50. So our I is equal to 50 is the final result for this integral. Okay, so this is all about this question. Okay, so is there any doubt up to now? We have discussed lots of property in definite integral. So most of the properties are basically, these are the important properties from which every year the questions came into JEE mains. Okay. Okay. So note down one question and try to solve this question in homework. Okay. So question is that fx plus fx plus 4 is equal to f x plus 2 plus x plus 6. This equation is given to us and we need to find out the value of x plus x plus 8 into fx. What is the value of this? Okay, we need to find out the value of this. Okay, so I think this is all about definite integral. We have discussed all important aspects of definite integrals. Okay, so in next class we are going to discuss area under the curve, or we can say application of integral. Application part. Okay, so let us end this session here. Okay, so can we end this session? Okay, bye bye. Take care.